In this clip, we are going to take a look at how to calculate point elasticity, which means we are calculating the price elasticity of demand coefficient at a particular point on a linear demand curve. For example, in the diagram at point B, we see that the elasticity coefficient is 4. This tells us that at point B, a 1% change in the price leads to a 4% change in the quantity demanded. Let's see how this is calculated. So it's the change in quantity So we have the change in quantity divided by the change in price multiplied by the price at point B divided by the quantity at point B. Note that this first part, so if we take a look, this first part is actually just the inverse of the slope or gradient, bearing in mind that we ignore the minus sign for our elasticity calculations. Note that this will be a constant value along the demand curve as it relates to the gradient. So if we go from point A to point B, so if we go from point A to point B to determine the inverse of the gradient, we have the following. The change in quantity is equal to 4 because at A it is 0, at B it is 4. The change in price is 2 because at A it is 0 and at B it is 8. So that gives us 4 over 2. So the inverse of the slope is 4 over 2, which is equal to a value of 2. Now, we could have moved between any 2 points on the demand curve, and the result would have been exactly the same. That is to say, a value of 2. The price at B is 8, so we now know what this value is over here. We know that that value is 2. So the price at B is 8. And the quantity at B is 4. So in our calculation, we now have the change in quantity divided by the change in price multiplied by the price over quantity at B. So this gives us 2 times by 8 over 4, which gives us 2 times 2, which gives us a value of 4. So at B, the coefficient value is equal to 4. Now, what you should notice for any linear demand curve, as can be seen from the diagram that we were working with over here, as we went down the demand curve, initially from a price of 10, the coefficient goes to 4, then to 1, then to a quarter, and then finally to 0, is that the price elasticity of demand is different at each point along the demand curve. So you should notice that for any linear demand curve, the price elasticity of demand is different at each point along the curve, varying from infinity at the vertical intercept, so infinity at the vertical intercept, to 0 when it meets the quantity axis. At the midpoint of the linear demand curve, the price elasticity coefficient is equal to 1. So at any price above this midpoint price, so for example, if this was a price of 20 at the vertical intercept, then this midpoint price would have been 10 Rand. So at any price above the midpoint price, the elasticity coefficient is greater than 1. So we say that demand is elastic. This means that a 1% change in the price leads to a greater than 1% change in the quantity demanded. At any price below the midpoint price, so below 10 Rand, the elasticity coefficient will be smaller than 1. So we say that demand is inelastic. This means that a 1% change in price leads to a less than 1% change in the quantity demanded. Now let's see why this is significant. In the table, we notice that as the price decreases from 20 Rand, so as the price decreases from 20 Rand, we go to 18 Rand, 16 Rand, 14 Rand, 12 Rand, 10 Rand, etc. The quantity demanded increases. That, of course, is in keeping with the law of demand. Notice what happens to total revenue. Remember, the total revenue is just the price times by the quantity. So the total revenue, as we decrease the price, the total revenue initially goes from 0, 36,000, 64,000, 84,000, 96,000, and it gets to 100,000. So notice what happens to total revenue. As the price falls to the midpoint price, the total revenue increases. So for as long as the price elasticity coefficient is greater than 1, so for as long as the price elasticity coefficient is greater than 1, that is to say we have elastic demand, the fall in price leads to an increase in total revenue. At the midpoint price, where the elasticity coefficient is equal to 1, let's just find a highlighter for that. So at the midpoint price, where the elasticity coefficient is equal to 1, the total revenue is maximized, in this case at 100,000. Now, as the price falls, so as the price continues to fall, try a different pen. So as the price continues to fall below the midpoint price, as the price goes from 10 to 8 to 6 and so on, although the quantity demanded increases, it also causes the total revenue to decrease. So for as long as the price elasticity coefficient is less than 1, okay, that is to say we have inelastic demand, the fall in price leads to a decrease in total revenue. Let's have a look at what this table shows us in the form of a graph. So the upper graph shows us that as the price falls from 20 Rand down to 10 Rand, try a different pen. So as the price falls from 20 Rand down to 10 Rand, so think of it as we slide down the demand curve, we find that our total revenue will increase. So as you slide down the demand curve, total revenue will increase, but that will only be true because we have an elastic demand in that portion of the demand curve. So for as long as the price elasticity coefficient is greater than 1, a fall in price leads to an increase in total revenue. Once again, notice that at the midpoint, the total revenue is maximized. Once we have decreases in price, when demand is inelastic, then that causes our total revenue to decrease. So the results are summarized in the blocks below. So over here we've got inelastic demand because the coefficient is less than 1. So we have inelastic demand over here, and we've got elastic over here. So you will notice that when we have inelastic demand, the total revenue moves in the same direction as the price change. It moves in the same direction as the price change. So when the price increases, total revenue increases. When the price decreases, total revenue decreases. On the other hand, when we have elastic demand, the total revenue moves in the opposite direction to the price change. So when we have an increase in the price, we find that the total revenue decreases. On the other hand, when we have a fall in price, the total revenue increases. At a price where the elasticity coefficient is equal to 1, the total revenue is at a maximum. Lastly, we take a look at the categories of elasticity. So when the coefficient value is 0, we have perfectly inelastic demand. This means that whatever the change in price is, there is no change in the quantity demanded. When the coefficient value is less than 1, we have inelastic demand. When the coefficient value is equal to 1, we have elastic demand. And when the coefficient value is greater than 1, we have elastic demand. When the elasticity coefficient is infinity, we have perfectly elastic demand.